Hello, everyone. Welcome to class 5 about how to rotate around accurate pivot point in UE4 C++. Today, we concentrate on J3, joint number 3, rotating about its pivot point. Let's open Notebook Tutorial 2. The J3 rotating similar to J2, rotating about the y-axis. The joint control, joint number, we change to 3. The same, the y value we give minus 45 degrees. Let's load C++ program back. The joint number 2, we can copy all the program of joint number 2. Control V and change the joint number 2 to joint number 3. If joint number 3, then joint number 3 minus greater, set relative rotation, new rotation. To avoid the influence of rho and yaw, influence the new rotation, we set new rotation dot rho equal to new rotation dot yaw equal to 0. Then, as the program running set the relative rotation, only pitch is used. And in front, we save new rotation to new rotation save. And after operation, roll back new rotation by new rotation equal to new rotation save. After the rotation, the J3 pivot point will separate it at the beginning. The pivot point of J3, suppose this is 0, 0, 0 position. The J3, the vector point to vertically to VP3 as rotating around minus 45 degrees. The pivot point rotate to these positions. Then the vectors from 0 to the new point, the vector like this. But we have to correct the new pivot point back to its original pivot point. So we have to opposite the vector from this point toward the original point. That's the reason why we need a minus in front. Minus VP RY, then the vector back to 0 point. And then to the original pivot points. So we have to 8 VP from these points add the vector back to original pivot point of J3, and the results become a vector. The component is SJ3. YJ3 and ZJ3. Actually, a 1 and real, because RY is 4x4 matrix operation. For better looking, we delete this one. Thereafter, we have create the SJ3 as flow and YJ3 and ZJ3 to use inside the program. And we prepared Y radius 3 for the sine cosine operation. We need a radius instead of degree, so we have to change the new notation pitch from degree to radius by multiply 3.1416f. This is the pi value, and divided by 180.0f. This is the degree as radius equal to 3.1416. Then we get the radius RAD3. Then the SJ3, according to the operation, derived as minus pivot location dot x multiplied by cosine bracket y radius 3 bracket plus pivot location dot z multiplied by sine bracket y radius 3 bracket, and then we have to plus pivot vector, and then plus pivot location dot x, the x value of the VP, and semicolon at the last. As rotating about y, the YJ3 is always 0. The ZJ3, the result, the equation as minus pivot location dot x multiply sine y radius 3 bracket minus pivot location dot z multiply cosine bracket y radius 3 bracket, and the plus VP in here is plus pivot location dot z. The z value of VP at real, and with a semicolon. After that, the y fn3 minus greater set relative location f vector sj3 yj3 ez3. After this set relative location, we'll let the new location shift to its original pivot point as the geometry of 6S robot showing on the screen is just like the J3 and the rest of the component rotating about the J3. Okay, let's compile. Press Ctrl Shift and B. The other rotating about Y positive direction is joint number 5. RY rotating about the Y positive axis. You can see this equation. Deviations at any computer-aided design textbook. Okay, the end. Once success, then go back to a real engine and to see the joint number 3 and the new rotation minus 45 degrees. So the J3 pivot point at here. So after this turning, it will turn to this pose. Before running play, we make sure the pivot point is correct. Watch the CMS CAPP's CSV table. The axis 3 is FN3. The pivot point S pivot is minus 15 in a real engine. Y0 and the Z pivot is 143.5. Let's see the program is correct or not. The pivot X minus 15, okay. The pivot location dot Y equal to 0, okay. Pivot location dot Z has to be changed to 143.5, like here. Okay, after corrections, we press Ctrl Shift B, recompile the program. Once success, then we can run the program. Minus 45 degrees about J3. Okay, play. You see? Correct. Then we give another value to the positive directions. 30 degrees of Y. So the arm will rotate 30 degrees down here. Okay, play. You see? The pivot point, the J3, no change the position. The rotating position is okay. So the class ending. Thanks for watching. Bye bye.